Okay, on the last problem we created a confidence interval for the number of programming minutes, and we used the confidence interval formula for a t-distribution because our sample size was small, and we're using a sample standard deviation along with the fact that our population distribution being normal. There are several rules about the choosing of the t-distribution. One way that works that's a little simpler than the book is to just say that if the sample size is 30 or greater, we will go with a normal probability density function and use the normal table. And if the sample size is less than 30, then use a t-distribution. And I will follow this for the exam, so that will help simplify a little bit of the little bit more detailed procedures that the book are using. That idea of having sample size greater than or equal to 30 for normal and sample size of less than 30 for a t-distribution is one model that works fairly well. So, and it's simpler to deal with. So I'm going to kind of go with that one as far as exam goes. So one thing you want to make sure when you're looking at an exam problem is to check the sample size. And if you're less than 30, make sure you're using a t-distribution. On the other hand, in this problem we had an average of 22 programming minutes, and our t-value was 2.093. Our sample standard deviation was 1.119, and we were using a sample size of 20. Now, the margin of error was about a half a minute for us. The margin of error part of the formula, along with our calculation, turned out to be, our margin of error turned out to be 0.5237. 0.5237. And that's about a half a minute. But suppose that I would like to have a margin of error of no more than 15 seconds. That's about a quarter of a minute. Suppose that I want, in other words, my margin of error to be equal to equal to 0.25. Well, I could just take this margin of error part of the formula and set it equal to 0.25. Now, I already know that my sample standard deviation is going to give me a good estimate, or hopefully a fairly good estimate of the standard deviation. What I'm going to have to do to get the 0.25 margin of error is to increase my sample size. With a 95% confidence, I'm going to use the 1.96 here. I'm going to have to increase my sample size large enough to get this margin of error to 0.25. Now, to figure out what that sample size is, all I really have to do is to solve this equation. I set my margin of error equal to what I want, the 0.25, and I plug in the values, 95% confidence. I'm going to use a z-value or a normal distribution value for that in this case, because my sample size will ultimately be large, I think, to get the 0.25. And as a rule, just use the normal distribution value. 95% confidence intervals, that's 1.96. For a 90% confidence interval, that's 0.05. So I'm going to go ahead and use the 1.96. Standard deviation, I can't change that. I can change my sample size, and I can increase it to be large enough that I would ultimately get this margin of error part of the formula to be down as low as 0.25. Now, the book has already developed a formula for us, and they started out by taking a z alpha over 2 to go ahead and just consider it normal because we're choosing for a sample size that many times will be large anyway. And then s over the square root of n equal to, and they're going to call this margin of error E. So basically, in solving for n, in terms of these other values, I get this formula on in the textbook that n is equal to the z alpha over 2 s over e, and then the whole thing squared. So you can do that algebraically if you want. That's an intermediate algebra type problem to solve that. But I'm going to go ahead and use that. Now notice one difference in the book. He does square each of the terms, and then he uses sigma. Usually you don't know sigma anyway, so I put an S in there. He uses sigma in his formula. But it's pretty much the same thing. So what I'm going to do is to calculate n, I'm going to put in my confidence z-score. I'm 95% confidence. I still want to be 95% confident, so I've got the 1.96. My standard deviation is, so I'm going to multiply by 1.119 and then divide the whole thing by the 0.25. Now, again, the book would have written this as just take each one of those values squared. So maybe I should go ahead and go ahead and simplify that a little bit. Take each of these values squared, so that's what I'm going to do. I'm going to take the 1.96 squared, the standard deviation squared, multiply those together and divide it by the 0.25 squared. And that gives me a sample size of 76.96, which I'll say 77. As a matter of fact, the book always says to round up. In this case, we would have rounded up anyway because it's 0.96. But even if it was 76.1, still round up. That way you're guaranteed to get the margin of error you want. So in other words, the bottom line is that if I go out into this population of 30-minute sitcom TV shows and I take a random sample of size 77 and recalculate a new point estimate, a new sample average, and then plug everything into the confidence level or confidence interval formula, I will get a margin of error of no more than a quarter of a minute. In other words, I will be, whatever that sample average taken from 77, whatever that sample average is, it will be within 15 seconds or a quarter of a minute of the real value.